So hi, it's, Bill from BioAg here with my coworker, Dr. Johann Buck. And we're here just to give you another little talk today. Johann, I got a question for you. Here we are in the greenhouse. Not part of my world, but this is your world, the controlled environment ag. And we're sitting here in the greenhouse, and you and I work with biostimulants. That's what BioAg does. And I get lots of questions from my growers that I talk to. But how do your growers perceive biostimulants? When you ask them about what a biostimulant is, how do they respond?
Great question, Bill. I think we get it all the time. And I think by and large, and I think this is also true in field ag, is the biostimulants are bugs in a jug, right? And biostimulants are still fairly new to the industry. I mean, as an industry, we're still kind of carving out, defining biostimulant. How do we register them? How are they used? Because biostimulants, let's be honest, it's a pretty broad category. I mean, it includes humic substances, plant extracts, amino acids, also referred to as protein hydrolysates, beneficial bacteria and fungi. So when you ask a grower biostimulant, it's kind of deer in the headlights look. I really don't know what you're talking about.
Right.
I use biologicals. Well, typically what they might be referring to is their biological program. So beneficial insects or biopesticides. That's a part of biologicals, but that's not biostimulants. And we already referred to what biostimulants are. So it's really then an opportunity to educate the grower in what biostimulants are and identify which products or which categories fit their system. You know, here we are in a greenhouse that's more of a shade structure, and I'll see a lot of environmental control. We have some irrigation, we have some walls to protect from the elements, some insulation on the end walls. So, yeah.
So, in my world of crop production, so big ag, field soils, in the elements, I understand, I get the microbiome, I get it. There are organisms living in the soil. They respond to stimulus, they respond to food sources, they're active in mineralizing micronutrients, macronutrients. It's a living, cycling soil. I don't understand how that works in the greenhouse, because you're not working with a living, cycling soil. Just tell me about that. That's foreign to me.
There are some similarities. There are a lot of differences too. You know, when we first started going into soilless production, soil was included. However, once you remove soil from the field, you change its physical structure. And that's what led to the development of soilless mixes like the Cornell peat light mix and the various formulations thereof. And in today, where we're using peat or coconut coir, rock wool, expanded clay, perlite, vermiculite, all of these soilless media components, right? And we're blending those together in formulations that suit the particular crop or category of crop that's being grown. So as you and I have discussed, and one of the things that I kind of use nowadays is the only thing missing from soilless agriculture is the soil. And at face value, that seems kind of, well, duh, because we know that mineral soil is not beneficial in a soilless media production system. Well, what I mean by that, when I started using that, is now I've had an opportunity to spend a lot of time in field agriculture over the years, a lot of time in controlled environment agriculture and soilless media. I mean, shoot, I worked on soilless research as part of my doctorate, right? So it's been really nice to play in all these arenas. There is some overlap, and we're beginning to really understand that in controlled environment agriculture, is that in the field, a tablespoon of soil can be rich with billions of beneficial microbes, and most of the microbes out there are benefit or not harmful. Many of them are beneficial. It's only when the system is out of whack that the bad pathogens and bad bugs and fungi will take over. Well, there's been this kind of concept over time in CEA that this root zone has to be sterile. It has to be devoid of life.
Right.
Well, we know,
because you're providing everything a plant could possibly need in the synthetic nutrition that it's getting.
Well, the attitude, and still to this day, in some circles, the attitude is that the root, the media, the substrate, is an anchor for the plant or a reservoir for nutrients.
Right.
That's all the plant needs.
Right.
But we know that's not true.
No.
We know through a lot of the work that researchers are doing, that we won't get into rhizophagy, but we were talking about this earlier, that plants may have even evolved to harvest microbes like humans harvest food. So how do we introduce those benefits to a soilless production system? A lot of companies out there have been offering products on the biopesticide side of things. So growers are familiar with things like trichoderma, mycorrhizae, for example. That's a biostimulant. It's a beneficial fungi that growers are becoming more and more, that they recognize more often. But now we're starting to incorporate into the system that's traditionally environment and nutrient, and then your pesticides. How do we fit, or how do biostimulants fit into that? And that's a challenge that we have in the industry, is to prove to growers that really biostimulants are a missing part of crop production and essential. I mean, plants evolved in soil with decaying matter. They've been in the presence of humic substances since they were growing in soil. So when those types of things are missing from a soilless media, there's a missing element there. Just how do we fit them in? We start getting into open systems versus closed systems and recycling. How do those ingredients fit? What pieces can we place where, and how do they benefit the plant? So it's a pretty exciting time to be working in this field. We have a long ways to go. I think as time goes on, as we see in field ag, in controlled environment ag, biostimulants are going to become a crucial part, and people will be saying, well, just as I have to have peat or perlite in my system, or nitrogen, phosphorus, I also need to have fulvic acids.
Yeah, and that was going to be my next question. So whatever you add to a soilless media, greenhouse system, you're still working with a soil devoid of biology. So your first step, so in that case, things like humic substance work as a true biostimulant to the plant, correct?
Correct.
And how does that work? And I mean, how does the plant responds to humic substance? Say, for example, our full power product. It's a low molecular weight carbon. How does the plant, or why does the plant respond to it? And what does it do for the plant?
There's a long list of benefits for humic substances and fulvic acids. Fulvic acids being the bioactive fraction of humic substances. We could get into we could do a whole video on just humic substances alone. But fulvic acids, again, are the bioactive fraction of humic. And for this particular production system that we're talking about, first and foremost, and kind of an easy introduction to the concept of biostimulants for growers in controlled environment agriculture, is nutrient use efficiency. We know that fulvic acids, based on the components that make up fulvic acids, which include carboxylic acids, phenolic groups, can complex with nutrients. So that's a pretty easy concept to understand. It's like, oh, add this, I have the potential to utilize my nutrients more efficiently. Similar to a chelated iron, right? More nutrients, more available, plants are better. Now we can start getting into increased ATPase efficiency in the plant, the proton plant and in the cell, and how fulvic acids permeate the cell membrane and help with cell division and elongation, which is why we see the oxen-like effect and lateral root formation. A lot of these are ancillary benefits that growers will see, but first and foremost, let's focus on something that you're very familiar with and can potentially help you, which is let's utilize nutrients more efficiently. Let's start there. And then we can discuss the other benefits you're seeing, such as, oh, my plants are a little bigger. Oh, my leaves are a little bit more, open and greener, and my plants are bigger. Why am I seeing this, that, and the other?
I got it. How would, you've been doing some work with BioSupercell, nanosilica in a fulvic matrix, spray applied, right?
And through the soil.
And through soil.
Through the root zone.
How would the addition of silica with the fulvic biostimulant, how would that improve plant growth?
Well, we're still kind of learning the benefits of those two together. Is it additive? Is it a cumulative effect? Is there synergy? We're still learning. Each one of those components has its benefits. Like silicon, as we know, structure, strength of the plants, abiotic stress relief, even reports of silicon when incorporated into the plant, changing the chlorophyll molecule in a good way, which is resulting in greener plants. Then we have the benefits of fulvic acid. Now, how are those two interacting and playing together? I mean, BioSupercell, for example, is a nanostructured silica. It's SiO2. It mimics the silica that you find in plants as it's been taken up in the plants and then converted back into silica. Taken up as monosilicic acid. The element silicon is what the plants utilize, and then converted to silica, right, in the plant. So, what's happening inside the plant with nanostructured silica? We're still learning those. We're obviously seeing the benefits, and growers are using it, and they're seeing abiotic stress relief. They're seeing greener plants. They're seeing more prolific roots. What's going on? We're still learning. It's exciting. It's kind of like, what do we have here? We have something.
Right.
What do we have?
Right.
But there's no doubt that both of those are helpful.
Right.
Which is why we've paired those chemistries together.
Right. And that's the other exciting part about biostimulants for me is in our modern ag world. So the greenhouse is the extreme of, or the most efficient, per square foot of production. The greenhouse is far more efficient than the field. But farmers, producers, growers, greenhouse growers, we've all gotten used to adding products to see a benefit. So show me what to apply or tell me what to apply. I apply the product and I see a response. We both know there's more to it than that. But I think what you're saying is with these biostimulants, the biostimulants that you've worked with, that effect does happen, especially over time, multiple sprays, multiple applications. It is a product you can add and get a true biostimulant effect.
Correct. And I do want to add to something you just said there. The greenhouse and vertical farming is very efficient. It's also very capital intensive. And therefore, if you're in a system where your sole source of lighting is an LED or high pressure sodium metal halide, it's supplemental lighting. And in some cases, those plants never see sunlight. You need to maximize every photon of light that plant is receiving. And we know that biostimulants, be it a microorganism or a substance, when applied to the seed, the rhizosphere, the plant, be it foliar or whatnot, enhances those natural processes that plants are conducting, including photosynthesis, which is why we will really start to take a look at how are those processes in the plants being affected, like net photosynthetic rate, or looking at chlorophyll concentration. Keeping in mind, plants are little factories, taking up nutrients, or converting sunlight to energy. And so how do we enhance those processes? Particularly if we're looking at biomass production, like in, say, the case of lettuce, where we're not looking at fruiting as we would be in tomatoes, for example. So very capital intensive. So we have to maximize those inputs.
Yeah, that all makes great sense. Johann, thank you.
You're welcome. Any other questions?
I have lots more questions.
I know,
but
we'll do this more often.
we'll end it there.
Yeah.
Good.
Right on.